Hello. Let's start the class on our first lecture on network theory. So basically, so let's just network theory, right? You have seen some glimpses of this topic or this subject in some of your previous classes. For example, you have done some uh, resistor networks and some sort of rectifiers. You have learned KVL, KCL, things like that in your previous courses, like your basic electrical and electronics engineering and your 12th or 11th standard. So you have some exposure to this. So what we'll be doing in this lecture is, first we'll start with some basics. We will go through the basic notations and symbols that we are going to use in this subject. So we'll begin with that, and then we'll take up some theorems, and we'll start solving problems based on that. Okay. So whenever we are talking about networks or circuits, so basically it is an interaction between two types of elements, which are sinks and sources, right? So what is a source? Source is something that provides energy, right? Provides energy to the system, to the whatever network or circuit or whatever it is, it will be providing some sort of energy. And sinks are elements which absorbs the energy. So this is the basic definition of what a sink and a source is. And sometimes what we identify as a source, for example, a voltage source, under certain conditions, a voltage source, what we identify as a voltage source, it may act as a sink. So it completely depends on the configuration of the network or circuit, which element is a source and which element is a sink, right? But that depends on individual networks or circuits. But in general, we can say, okay, certain elements are sources and certain elements are sinks, right? So let's see. Before going that, consider this. This is a generic element. It can be anything, right? So the basic notation is that. So what is this? This plus and minus. This shows the polarity of the voltage dropped across this element, right? So this point here, it is at a higher potential compared to this point, and suppose this is the voltage V that is dropped across this element. I am assuming that you are familiar with at least this basic notation. Okay, so this is the element, and again I am drawing something similar to this. I am again using a similar notation, right? So here again this point is at a higher potential compared to this point, right? So when we talk about a source and a sink, one major difference is that the current I, right? The current I, for a source, the current behaves in a different way relative to the potential than a sink, right? That is, for a source, that is whether the current is leaving the device or entering the device or the element at the higher potential or lower potential. That is the basic thing, right? Here current is entering here, current is leaving here. So this is a major distinction considering or regarding whether this is a sink or a source, right? So as a rule of thumb, Once you identify all the potentials and currents of a network, if the current is leaving from the positive terminal or the higher potential, this will be a source, right? This will be a source. And if the current is leaving from the negative terminal or the lower potential, or the other way around, if it is entering from the positive terminal or the higher potential, this is called as a sink. Mind you, you shouldn't saying a positive terminal and a negative terminal is not always a proper notation or representation when it comes to let's say certain elements. So let's use the higher and lower potential notation, right? So again, just to reiterate, if the current is leaving from the higher potential point, it is a source. If the current is entering through the higher potential point, it is a sink. Okay. Right. Now let's see which are the different types of sources and sinks which is coming under this subject, or which we will be dealing in this topic, this paper. Okay. So first of all, right, this is a voltage source. This is a voltage source. So we have this round notation. The voltage will be written in capital V. The current which is going out of the higher potential will be termed as small I, right? So capital V and small I. Then we have the current source I, where the current source, right? So here we have given capital V for the voltage because it is a voltage source. Likewise, here, since this is a current source, we are giving the capital letter for the current, and here we had used small letter I for the current. So here we are using small letter V for the voltage. Again, and this arrow signifies the direction of the current. So the current will be going like this. And again, this is in keeping with the previous notation that we mentioned or discussed about. About sources, right? That is, the current leaves from the higher potential point. So this is a DC voltage source. Let me add it. This is a DC voltage source or a DC current source, right? So how do you distinguish from a or rather, what will be the notation of an AC voltage source? It will be something like this, right? That is, there will be this AC signal in between the positive and negative. Similarly, what will be the notation for an AC current source? The current will be there, and again this AC signal will be used to denote that it is an AC source. That is the only difference with regards to notation, right? And yeah, that is it. So this is the let's say active devices or sources that you will have to deal with for the time being. Now let's move on to the passive devices. So in this course, you will have to deal with 3 passive devices. The first one is a resistor, right? This is a resistor. So what is a resistor? A resistor is anything that, any element or any device that shows the property of resistance, right? Any element that shows the property of resistance is called as a resistor. And what is the relation between voltage and current for a resistor? It is V equal to IR, and I am sure you know what this is. We will come to that in a little while. Okay, so we have a resistor. This is the circuit symbol, and anything that shows resistance is called as a resistor. This is the voltage and current relation. So the next element that we will be dealing with is, it is called as an inductor, right? Again, it is inductor is any device that shows inductance. So, and again the current voltage relationship will be V equal to L di by dt, right? And moving on, we have the capacitor. Capacitor is anything that can show capacitance or that exhibits the property of capacitance. And the current voltage relationship here is I equal to C dV by dt. So we will be dealing with inductors and capacitors later. First we will be dealing with resistors almost exclusively. So keeping up with the notation of voltage and current in the for sync that we discussed earlier, how will we denote the current and voltage here? If the current I enters through here, the voltage will be like this. Again, if the current I enters through here, the voltage will be like this. Again, if the current I enters through here, the voltage will be like this, right? Okay, one thing I missed in the previous part is that for an ideal, okay, for an ideal voltage source, the internal resistance will be 0, right? Internal resistance will be 0, and for an ideal current source, the internal resistance will be infinite. That is, if you are to replace this source, voltage source, with its equivalent resistance, then it will be a short circuit. That is, if you want to represent this circuit or this voltage source without the voltage, just the internal resistance, right? Because we will have to do problems or tackle issues where you consider just the internal resistance or impedance of the sources. In that case, this will be a short circuit, right? Here, what does it mean? Internal resistance is infinite means if we are to replace this voltage current source with its internal resistance, it will be an open circuit. This is for a ideal voltage and an ideal current source. Remember, for it is an ideal case, and we will do problems in which there are in which the voltage sources and current sources will have some sort of finite non-zero infinite internal resistance. We will come to that. Okay. So before winding up this lecture, let me give one more small definition. Okay. So I am drawing two figures here, right? So let's say number 1 and let's say number 2. So what is the difference between 1 and 2? Okay, what is the difference between 1 and 2? Like it is obvious, right? Like this element, this portion, this arm or this resistor is not connected in both sides. That is, when we are giving the voltage here in this figure, this image, the current, some current will be flowing through all the let's say path, right? If you are not taking any other extraordinary condition, by default we are assuming that all current is passing through or flowing through all the paths. But here currents are not passing through all the paths. Here current won't pass because this is not closed, right? So this is the basic difference between a circuit and a network. Circuit, so what is in a circuit? All the path will be closed, all paths will be closed, and current will be passing through all. Here all the paths, it is not a necessity that all the paths are closed. There can be open paths. So in reality, most of the things that we see are networks. Circuits are sometimes not always possible. Most of the things that we see are networks only. Okay, so let's have a recap of this lecture, and with that we will wind it up. So we started with the definition of a network, or the whatever we are doing here. It is as an interaction between sink and number of sinks and number of sources, and we gave a definition regarding what is a source and what a sink is and we had a little bit of representation. For a source, the current will be going out of the terminal which is having the higher potential, and for a sink, the current will be coming in through the terminal that is having a higher potential. Then we moved on to show some of the different types of voltage sources. So let me draw it like this. So we have an ideal, we have a DC source, DC voltage source, and a DC current source. The notations are given like this, right? And we have a AC voltage source, and we have an AC current source. Okay, and later we mentioned that for an ideal voltage source, the input resistance will be 0, and for an ideal, internal resistance will be 0, and for an ideal current source, the internal resistance will be infinite. Then we discussed or we introduced the 3 major passive elements that we'll be dealing with in our subject, which is resistors, inductors and capacitors. The circuit symbols for the same, and the voltage current relationships, right? And the last topic we discussed is the difference between a circuit and a network. So with that I am winding up this lecture, and in the next lecture we will start with some basic theorems. Okay, thank you.